Hello P6, welcome to Monday's Maths. Now we are going to get underway for this week with some emojis and we're going to do an emoji code breaking activity. When you download your page, you will see that at the top of your page you have got a set of emojis right up at the top, and each emoji has its own numerical value. So anything from 0 to 1, 2, 3, 4 all the way up to 9. Each of them has a different value. Now what we're going to do today is use these emojis to break the code that's underneath, and we're going to see if we can work out what each of these numbers is actually worth, and then do some adding or do some subtracting. So for example, in the first one, okay, so I'm looking to see which two emojis these are, which numbers they're worth. So this one, this very happy face, is a 5, so I'm going to write down a 5. I've got a mouse, the mouse is worth 3, so that number is 53. Add, so that one's 4, and that one is 1. So the question I have is 53 add 41. What's 53 add 41? We'll add my tens, 5 tens and 4 tens, that's 9 tens, so 90, 93, 94. So I write my answer in on the line. So what you're trying to do today, P6, is use the emojis at the top and the code and see then if you can work out the answers to your calculations. So that's our warm-up. Our main activity today, well, you will recognise these words from P5. Do you remember the words area and perimeter? Today we're going to be concentrating on area, but I would love for a moment for you to have a think. Can you remember what each of these words mean? Can you remember what the difference is between the two of them? Have a little chat with somebody at home. Pause the video just for a moment and see, can you remember what the difference is between area and perimeter? Pause the video now and have a little chat. Have you had a think about it? Okay, well, let's see if we can remember the difference. When we're thinking about area, we're thinking about the surface, how much of the inside of this shape has been covered, and we measure it using squares. Perimeter is the distance around the outside edge. So we're not worrying about what's happening on the inside. In perimeter, we're worrying about the fence almost around the outside of the shape. But area, which is what we're going to be thinking about today, is about the inside of the shape, the amount of surface that is covered by the shape. Now, you'll remember from P5 then that we can measure area in square centimetres. And you remember in P5 writing it down like this? So we write cm for centimetres. And then because we're looking at squares, we put a little 2 up high. So we are measuring the amount of surface covered by a shape, and we measure area in square centimetres or centimetres squared. Now, on the page that I've got in front of me, each of these shapes that you see they're all rectangles. Each of these rectangles is made up of lots of individual squares. Now you'll remember back in P4 when you first started looking at area, the easiest way to work out the area of a shape is simply to count the number of little squares that I can see inside it. So if I was to pick this yellow one, for example, the easiest way for me to work out the area would simply be to count all the squares. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if there are 18 squares inside it, I would write down the area as being 18, and then beside it I put my centimetres and I put squared. Let's pick another one. Let's go for this purpley pink one here. Shall we work out the area of it? So we'll count the squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I could say that the area of this shape is 24 centimetres squared. So the easiest way to work out the area is simply to count the squares. If you can see squares, of course. If you can't see them, that's a little bit harder. So that's what you learnt how to do in P4. Now, in P5, you learnt a slightly better way to work out the area, perhaps a quicker way to work out the area. Can you think for a moment what it was? Well, did you notice anything about these shapes? Did you notice that there were 12 across there and that there were 2 going down? 12 across, 2 going down, and we got the answer 24. In this one, there were 6 going across, there were 3 going down, and we got the answer 18. Is it coming back to you? Well, what we learnt in P5 was that a quicker way, rather than having to count all the individual squares to work out the area, is, if we think about the area, we multiply the length times the breadth. Length and breadth. So we've got the length, we've got the breadth, and we multiply the 2 together. It saves us having to count all the individual squares. So let's have a look at these shapes, these yellow rectangles, and let's see if we can work out the area of each of them. So let's take the first one. So we're not going to count every single square. We're going to measure how many there are going across and how many there are going down. So shall we look at the first one? So going across, I've got 1, 2, 3, 4, 5, 6. So the length is 6 centimetres. What's the breadth? Well, let's count down. 1, 2, 3, 4, 5. So there are 5 going down. So I've got 6 centimetres, 5 centimetres. I multiply the 2 together. What's 6 times 5? P6? Yep, it's 30. So the area of this one has to be 30 centimetres squared. I could prove it to myself by counting all the individual squares. So I could go back and count 1, 2, 3, 4, 5, 6, 12, 18, 24, 30. I could count them all. But we learned in P5 that we can multiply length times breadth. Let's work out this one. Shall we count them? So what's the length? What's the breadth? The length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 going across. How many can you see going down? 3, yep. So what's the area of this one going to be? 10 times 3 is, it's also 30 centimetres squared. These two shapes have exactly the same area. They're not exactly the same rectangle, but they do have exactly the same area. Let's go on to this one. Let's work out the length, let's work out the breadth. So let's count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 going across. So it's really important that we write that down. Don't just try and remember it. How many going down? 2. So what's 2 groups of 13? 13 times 2, double 13 is going to be, yep, so that one's going to be 26 centimetres squared. Let's work out the area of the last one. So length times breadth. 1, 2, 3, 4, 5, 6, 7, 8, 9 going across. How many going down? 1, 2, 3, 4, 5, 6 going down. So what is 9 times 6? 9 times 6 is, yep, 54. So the area of the final rectangle is going to be 54 centimetres squared. Remember, area is all about the amount of surface. It's about the inside of the shape. So how many squares are inside it? Now today, P6, for your tasks, you're going to choose one of 2 levels. If you choose to do the higher level activity, the shapes that you're looking at today, they don't have individual squares on the inside. So you are simply going to be multiplying. So you're going to be taking your length, which is 6, your breadth, which is 3, and you're simply multiplying. If area equals length times breadth, then you're doing 6 times 3. What is 6 times 3? Yep, it's 18. But what do you need to put after your answer, P6? You must include that centimetres squared. So you are going to be multiplying. So that's your first part where you're going to be doing some multiplying. Once you get on to the second part of your activity, you're being given 4 different shapes, and what you have to do is work out once you've worked out the area, can you order those rectangles from the smallest area to the largest area? So that's the activity that you're going to do if you choose to do the higher level activity. If you choose to do the lower level activity, then you can see that you've got the little individual squares inside your shape. So what you can do is, yes, you can do your multiplying. You can do your area equals length times breadth. You're told it's 4, you're told it's 2, so multiply them together. But then you can prove it to yourself by counting the squares. Because if the length is 4 and the breadth is 2, then 4 times 2, of course, is 8 centimetres squared. But then I can prove it to myself by counting the squares. Are there 8 individual squares inside the surface? Yes, there are. So for your activity, if you choose this one, then you have got lots of different shapes to do, just like that. Okay, so have a go at lots of them. And then when you get on to your second part from question 21 on, again, you have to order the rectangles from the smallest area to the largest. So look at these, work out the area of each one of them and then sort them. Which one it has the smallest area through to which one has the largest area. So those are the main written activities for today. Now, once you've got those done, I would love you to play a game. So on the website, you can download this Capture the Island Area Challenge. And it's a 2-person game, so challenge somebody in your house. There is a set of instructions. Then you're given a set of coordinates and you're also given a map. And what you need to do, piece 6, is, well, you need to take these sets of coordinates and go and cut them out. So get some scissors and cut these out into individual cards. Take each card and turn it over, okay? So turn it over on the table. And then what you and your partner do is you take it in turns to turn over a random coordinate card. Now, let's say that the coordinate card that I turned over was this one, okay? So I've got the coordinates 1, 3, 1, 4, 3, 3, and 3, 4. Well, what I would do is I would use my coordinates grid and I would plot those points. So 1, 3, so remember 1, 3 means I go across 1 and up 3, so I'm going to put a little X there. 1, 4, so 1 across, 4 up. 3, 3, so 3 across, 3 up. 3, 4. Join those points together with whatever colour you're using. Now, how many squares are inside it? What's the area of the islands that you've just drawn? Well, it's got an area of 2. So if that was me playing, and I'm Mrs. Bell, so I'm going to write Mrs. B inside that, and I'm going to put a 2 in there, I would win that island, and it's worth 2 points. And then whoever I'm playing against, they would turn over another card. So they might turn over this card. They would draw this one out on the coordinates grid, work out how many squares are inside it, and see how many points they can score. The winner is the person who, at the end of the game, has captured the biggest number of squares, okay? So have a go at playing the Capture the Island Area Challenge against somebody in your house. And then piece 6, if you've got all of that done, why don't you go on to Prodigy? We had more wonderful scores again last week on Prodigy. Some of you are doing such fantastic work there. Well done. Keep it up. If you haven't been on to Prodigy yet, it's never too late. All the details are on our P6 homepage, so go and log on to that and go and find out how to get into Prodigy, what your username and password is, and get started today. And if you've still got time, go into Education City and go and play live. Bye.